Okay. Oh, my back hurts. Well, similar to last time, I also spent some hours trying to prepare for today's live stream, like I always do. I prepare some parts about basically reviewing the stuff I've done, because it has been so long since the last time I've done about the pendulum stuff. I believe it's, I don't know, like several weeks ago. So to keep myself reminded and to review what I have done and where I left off, I spent some hours, also with GPT of course, and prepared something for today's live stream. My head honestly hurts a little bit right now, and my single strand of hair keeps attacking my cornea, but that is negligible as the stream goes on, because today's live stream will be so heated, it will be so epic, and I will be explanatory by performing of today's live stream. Okay. Okay, I have to remind myself, keep monitoring myself, and not to forget about that I am, if I'm frozen or not. Keeps happening since yesterday, I don't know why, still haven't figured out. So, as you can see on the right side of the screen, I've filtered out some slides on the Krita file that seems unnecessary to exist. So I saw them out, they're filtered out, and we're starting off with the slides that is nutritious, and we're starting off from there. We finally have gained the experience and knowledge about the Jacobi elliptic functions, and we will finally put that into use. So, shit, hold on. Okay. Yeah, so we started off from here, and went through this one, and went to here, and we will start off from here. The last time, we were informed that this is not the standard elementary level of integral. It requires some big boy integral system, and that was Jacobi elliptic functions. But if you remember the last stream, Jacobi elliptic function was the Jacobi amplitude, especially the Jacobi amplitude. Jacobi amplitude, it looked kind of like this. It looked... Oh shit, what was it? Yeah, it was this one, FP. It was the inverse. Wait a minute. Yeah, it was the inverse of incomplete elliptic integral of the first kind, which was this. K squared. It doesn't matter. Okay. Wait, does it matter? Was it k squared or k? It's k squared. Okay. This is the incomplete integral, elliptic integral of the first kind. And if we inverse it, then it will turn into Jacobi amplitude, which is the outcome will be Jacobi phase angle. But look at this shit right here. This does not look like this at all. And while reviewing this, what the fuck? This should be. Why did ChatGPT told me that this is Jacobi elliptic function in the first place? It turned out, it can be changed into the thingy, but requires some additional information. Okay, so I believe it went something like this. It was the approximation process. We had to go through the approximation process, and it was not the approximation, the substitution process. And this was, I wasn't able to understand this at the first place, and you can see why if I write this down. If I remember this, okay, sine okay, and k is equal to sine theta 0 over 2, and theta 0 is the initial angle. So if you just look at this right here, there are two sine functions, and originally, first off, this sine, it varies from 1 to -1, and right here in this side, the sine value, the sine theta over 2 varies from -1 to 1, and this should also too. Then I thought to make this always possible, the k always has to be 1, nothing else. And there is no need to leave a place for a k to be a variable. And the reason why that's not correct is kind of very obvious, because this equation is not part of a progress of finding the value k. It's just simply a calculation. This is a value, and this is also a value, and k, this is also a value. The sine theta 0 over 2 is equal to k, and we're just gonna substitute. This is substitute progress, substituting this thing into k. So this is a constant. Yeah, this is a constant. Well, of course, this value will change depending on our preferences. Like if you want to drop a pendulum in here, then the theta 0 will be this one. But if you want to drop a pendulum in here, then theta 0 will be this. And if you don't want to drop a pendulum at all, then why are you here? So that's it varies. It varies, but the k, it can be seems the constant, and sine theta over 2. Theta is a function of t, so the theta value depends on t, and phi is a set of function which is phase angle, also depends on t. And I don't think no further explanation is required to explain this, because you guys are smarter than me and you probably understand what this means. Yeah, so it just k is this value, and the theta function of theta depends on t. Well, it exists. Something kind of looks like this, and at some single point of t right here, this is the value of sine 2 theta, sine theta over 2, and I don't know, maybe the sine phi value might be here, and this is sine phi value, and this is sine theta over 2 value. And as you can see, those two are not the same. But in order to make it the same, we can multiply the sine theta 0 over 2. So, yeah, that's basically it. So, that's what it is. I think I don't have to explain this further. We're moving on, and using this, we can substitute this whole giant section right here into the Jacobi elliptic functions form, the integral, the first kind. Why is it so hard to memorize that name? It's not that that word doesn't consist much syllables, but it just makes it feel difficult for some reason. Okay, I can do this. We're going to manufacture this equation right here. I'm also really hoping that today's live stream is also going to be very short live stream. But then again, I'm hoping. What I am desiring right now is that I would really, really love to. The hell did I just do? Yeah, I would really, really love to let this today's live stream under an hour. But you know, the obtaining the function of theta is actually not the goal for today's live stream right here. So, I don't know, this stream might be longer than the latest one. We're starting off from here. We also need this, of course, we should not forget about it. And we all know that cosine theta is equal to 2 cosine theta over 2 minus 1. And we're going to use this on this equation right there, which is exactly actually this one. 2 pi. Is this correct? I'm not making any mistake. Yeah. Then the cosine theta minus cosine theta 0 will be equal to 2 sine square theta 0 over 2 minus sine square theta over 2. Right? I think it's right. Oh, my ears. Ooh. I sometimes really wonder because I wear earphones kind of frequently and a lot. Because I make music and I listen to music. And I basically wear earphones almost all the time. Well, not that much because I pretty much, but not that health risking level of much because I care about my health and I don't want my ear to go through the irreversible damage or something. But still, I'm the kind of person who wears earphones kind of frequently, and I have heard that the habit of wearing earphones might lead to the hearing loss. It might not be a very surprised news. It's kind of might be very obvious, but wearing earphones frequently, it also means that you wear your earphone, and you have to repeat the sequence wearing it and wearing it off. And by doing that, you're basically putting the lint, dust, or all those kind of tiny teensy weensy stuff into your ear, and it will accumulate inside your ear, eventually making up a earwax. Yeah, so that's basically what the earwax consists of. The bodily fluids, like your naturally generated oil or secretion of your cells, and like I said, lint and dust combine and makes into a sticky earwax. But the more input of the lint and dust, it equals the more accumulation of the earwax, which will block the ear canal and make it difficult and impossible, sometimes impossible, to sound waves go through to your eardrums. Or sometimes, if there's like crazily fuck tons of earwax in your ear canal, then there's a chance that when you're wearing earphones, you will push those earwaxes towards the eardrums and have a risk of rupturing the eardrums. And well, that's a thing that is not impossible. But although I think to make that thing happen, you have to like accumulate your earwax for 7 years without taking them out. But it is not impossible. So, yeah, I just had to brought that out of my brain since I was my ear was itchy. My ear was itchy for like 3 minutes ago. I hope you guys are eating right now if you're watching this for the experience. Okay, where did I left off? It's sine 2 sine squared theta 0 over 2 minus sine squared theta over 2. Yeah. This will be... Yeah, sine theta 0 over 2 is equal to k. So 2k squared minus k. Okay, sine theta over 2 is equal to k sine phi. So k square of k sine phi is k square sine square phi. And now I realize, hey, this is kind of looking similar to the one that we have seen on the Jacobi elliptic function. And yes, this is exactly what we're going for. This is exactly what we're doing. Yeah. Okay. Wait a minute. Hmm? K squared 1 minus sine squared. Okay. And this will be 2k squared cosine b. Yeah. Yeah. I think I'm doing this correctly. Square, cosine square b. a제곱 1 마이너스 사인제곱 b 하면 코사인제곱. Okay, had to pause there for a little bit moment because it seemed kind of different from what I have rehearsed. It's okay. And we're gonna put this back into the first thing. Then it will be L over 2g integrate. K root 2k square cosine square phi. And we also have to consider about the d theta too. We're going to differentiate this equation. Then it will be sine d theta is equal to Wait, is this not correct? This something fishy about. Okay, I'm currently looking at the part where I have researched. Yes, and you don't have to look at what I'm looking. So hold on. Am I doing something wrong? Sine theta over 2 is equal to k sine t. And k is equal to sine theta over 0 over 2. No, it's correct. I think it's legit. I hope I don't have to worry about if I'm doing this wrong or not. Anyway, and this will be k cosine b d phi. Yeah. 뭔가 자꾸 아닌 것 같은 생각이 들지 이거? Okay. Okay. Cosine theta over 2 is equal to 1 minus sine squared theta over 2, which is 1 minus k squared sine square t. And root, of course. Very important. Okay. Then d theta. Oh my god, the d theta will be equal to, hold on, I'm gonna practice this a pink arrow, just indicating can be derivative from that. D theta is equal to okay, 2k cosine b d b, and there's a root of 1k square sine square b. Yeah, there we go. Okay, do you remember what I said about this kind of looks like, it kind of resembles the first kind of the elliptic integral. Fuck that idea. This is actually the one. This is actually the thing that would contribute of the lookalike of the integral of the first kind. Elliptic integral of the first kind. Yeah, so I think I didn't make any mistakes. I think we can move on. D theta 1 and times basically the same thing. I'm just gonna copy and paste. It's a funky looking, but it's okay. And let's see what we can do in here. So the cosine square phi, and there's a root, which is a cosine phi. That means it can be erased. Cosine phi will go away. There's root 2, there's 2, and it will be turned into root 2. And there's k, and the root k square, root of k square will turn into k. So there's k, and it will be all gone. The only thing that is left is this one right here. And so it can be turned into root 2 will come out of the integral. It's a constant, and there's root 2 over in the denominator. So it will compensate, and it will vanish, of course. It will turn into root of L over G, integral of root 1 minus k square sine square b d phi. There we go. So that was why this can be turned into integral, incomplete elliptic integral of the first kind. That was why. But a t, we finally got the value of t right here. T is equal to this one. And what we now have to do is get the function of theta, and then we can finally move on from that. Okay. Okay. The value. first kind is equal to, we're gonna move the root of L over G onto the left side, which will be root of L in denominator, G on the numerator, and the T will be right here. Okay, and we're going to inverse it. We're going to inverse it. And we remember what happens if we inverse the incomplete elliptic integral of the first kind. Hold on, I want to abbreviate this. Incomplete elliptic integral of the first kind. Okay, I'm gonna name it elliptic. Sounds like I'm saying fuck. Maybe this is not a good idea. Okay. I'm just gonna ignore it. Maybe that would help. And if we inverse it, then it will be amplitude, turn Jacobi amplitude, which is Jacobi amplitude root of G over L K equal to the phase angle here. Yeah, and we are almost done. We're almost done. We can. Okay. We're gonna start off with this point right here. And also we need these two for help. Okay. We have the Jacobi amplitude. And we actually made a substitution with this right here. And this is actually our advantage. The sign addition right here, it can be turned into theta over 2 is equal to inverse sine of K sine. Now we can just name it as Jacobi amplitude G over L, comma K. Excuse me. Yeah. And it's done. The theta is basically sine inverse 1, sine inverse sine of K, and notice this one right here, sine of Jacobi amplitude, which is this one right here. Yeah. What's it called? Yep. Jacobi sine? I think that's not the correct word. The elliptic sine of G over L, comma K. And there we go. This is the answer. This is the value of theta. I think I missed something right there. Yeah, I knew something was wrong. I was like, hey, wait a minute, the theta is a function about t. and there's no t in the variables. Something might have gone really wrong. And yeah, something was wrong. Yeah, okay, I think, yeah. So this is the answer. This is the answer for the theta value, the function depending the variables of t. You can expand it without substitution. It will be long. Oh, wait a minute. I think I have to write it in a different paragraph. 2 sine inverse 1. A is sine theta 0 over 2 times elliptic sine of root of g over L e, comma, A is a sine theta 0 over 2. And yeah. Okay. Now we finally got the value of the theta t. And now here's the problem. From here, I actually didn't rehearse, so we're gonna just straight up bump our head into the concrete. We're actually gonna do some research, the actual research, because, like I said, I haven't went this far before preparing this live stream, and for this part, I think I have to come back and continue after the bathroom break. Yeah, hold on. Fuck, I missed your comments. Okay, it's okay. Welcome. What did you say? You I just got here. Are you using small angle approximation or elliptic integrals? I'm using... I'm... Sorry about that. I'm using elliptic integrals. I should have never thought about the physics in real life without the abundant approximation. I've never thought about that until I have thought about this idea and doing this on live stream. Yeah. Oh, elliptic integrals. Okay, excuse me for a second. When I... What's that word? Devour the breath through my throat. The part that I'm going to do right now is actually going to require some energy. God damn it! Why did you have to come to my live stream? Exact point when I was having a bathroom break. Unbelievable. Okay. On. Have I been too silent? Sorry about that. The bread is actually. What was that word? What was that word the young kids fellow used? The lit? No. There was a specific word that bustin'. Yeah, I was wondering about the word that best describes that. It's awesome. It's exponentially good. It's marvelous, but into a very brain rot Zen alpha skippity way. And it might be very dishonest to think of it that way, considering my age right now. But every time, every day, there's always some moment that you just want to get along with the fellow kids. The want to be young again. A skibidi toilet, I really highly disapprove that. That's a fucking shit. I have no respect on that. But lit, busting, those are the words on the internet for a while, about a few months ago, maybe a year ago. But I think I also remember it didn't last longer than 3 months. It's already all well-known fact, even to everyone, among everyone on the internet, on the universe, is that the memes die very quickly. They don't last long than it used to in the back in the days when, I don't know, 2010s or early 2000s. And it has been like this since 2017, I think. Yeah, do you guys remember? If you're watching this, and I hope that you're around my age, and I'm really hoping that you will remember the Uganda knuckles. And that meme quite went very long, and its life expectancy was quite long, and I believe it was a year, a whole solid year. And the Bombardillo Crocodillo Assassino Cappuccino, and that's I think it lasted 3 weeks. Am I right? And it's going to get shorter even from now on. And when it gets shorter, every time the year passes, do you think that there will be a limit of the shortage? Like it will eventually get summed down, get diluted down into a single set of time. Like there's no limit. I mean, there's no downwards from this point. This is the limit. For example, at 3 seconds, the meme lasts 3 seconds, and that's it. No limit. Or it really like gets shortened down. The duration gets shortened down really exponentially without any limits, and there are just no meme that's being alive because it doesn't even get to start born with. Like I think we can put it this way. There's a box. Now prepare yourself a box, a giant crate, and put a marble inside it. And there's only going to be one marble. And let's imagine that you're in a solitary room, and you're stuck in there for like 54 years. And only thing you have to do, and the only thing inside the room is a crate and a marble. And there's one marble, and you'll feel like excited. You can do a bunch of stuff. But the marble, you can roll it around, or maybe poke it a little or something. Yeah. But as the time goes on, the more and more marbles come in, and eventually, you seem to like either one marble, two marbles, and you start to name the marbles. The marble number one as like, I don't know, Paul. Marble number two, Leslie, something like that. But as the marble goes, it's increased. The amount of marbles gets increased more and more, and eventually reaches like thousands and 10,000 millions of marbles inside the crate. At some point, you will stop naming or marking the marbles, and you will just see the whole giant ass marble collection as a whole thing. You will not see the exact every single marble as like more concentrated than the whole thing. Like, there are millions of marbles. You will not carry every single one of them. And in fact, the whole notion of the collection, thinking of the collection itself starts to build up at one point. And starting to care about each meme as their presence, each marbles will fade away and will just turn into a whole ocean of marbles. And there will be, and this is my pure guess right here, there will be a new form of something. I don't know if it's going to be a meme. I think that's going to be totally something else. It will probably not a meme. It will be something that has been not existed yet, but it will form out of the diluted and polluted ocean of memes and internet culture. Okay. Now, this would be very interesting. Okay. X is minus L sine theta. And no, minus L sine theta. Minus L cosine theta. Okay. Minus L sine theta. Sine theta. Minus L going to be minus L minus L and this whole giant ass thing. There might be a way to simplify this. Right there. Okay, this will go over this side. Now, I don't think there's any way to simplify that. I'm not gonna risk it. I mean, I'm not gonna try it. Why did I say risk it? As if like, it's a matter of life and death. No, I'm not gonna try it. Instead, I'm going to try derivating it. I mean, differentiating. That's what I'm going to. Okay, because that's basically what I'm. No, wait a minute. That is not what I'm trying to do. Holy shit! Why was I trying to get the velocity of the each axis, x and y axis? I mean, I could do that, but I'm not gonna do that. Because this is actually our goal right here. Trajectory of a pendulum, the x and y coordinates. Okay. Now hold on, let me double check if I actually did the things correctly. You might not be able to see what I'm doing here, but it's not gonna take long. Do inverse line. What the hell? Okay. Fine. Okay. Just then root E. And y would be y. Minus L sine the same thing. And this is the answer. There we go. How do I mark this? I'm gonna mark this blue. That's the answer. Huh. But we're going to input this into a GeoGebra, but before actually typing this whole chunk of equations into the GeoGebra, I think I have to test it out first. I should have never made it. What? Never made an attempt to input the Jacobi elliptic functions into GeoGebra, and I'm not even sure if it supports that. The last time I searched on Google, it said that it didn't. It has no feature of supporting the Jacobi elliptic function. Who knows? This would yield nothing, right? Jacobi elliptic function in GeoGebra. Is there an easy way to plot Jacobi elliptic functions with whatever that is? So the Jacobi elliptic functions are a little bit tricky to plot because they depend on a complete elliptic integral of the first kind that can be written as a sum of doubles factorials. And the Fourier series for the Jacobi elliptic functions then depend on exponentials of these elliptic integrals. I can easily write all the mathematical formulas, but I don't know an easy way to represent them on PIX or PGF. I think those are the softwares, I assume. Probably GNUPlug would be the easiest. Wait a minute. Double factorial? Oh! Oh! 잠깐만. I can't tell more because my mathematical ability is limited. The following completed code in asymptote can be compiled on asymptote alberta.ca. Asymptote, the vector graphics language. Asymptote is a powerful descriptive. Is my Google the fuck thing is not showing right now? Of course. Okay. Asymptote, a powerful descriptive vector graphics language that provides a natural coordinate-based framework for technical drawing. Labels and equations are typeset with LaTeX, the de facto standard for typesetting mathematics. A major advantage of Asymptote over other graphics packages is that it is a programming language as opposed to just a graphics program. I don't know. I'm not much of a programming guy. Does it have elliptic? Jacobi. Maybe it's not a thing that is technically what I'm looking for. Okay. Import graph, import GSL. let me try Control C, Control V on here. And okay. Oh, there's run. Oh, okay. Yeah. We don't need labels here. I have never learned computer programming or coding in my entire life. What am I doing right now? What if I do this? Will it just like return an error or something? No. Okay. So I will disable the label, but God, G graph, SN, U. What is going on here? Okay, new real SNU, real K, int, what is int? Integral? Integer N. Per new real. And from 0 to I can probably... Okay, so following these coding, I can probably plot these into here. But do you know what? I have a better idea. Yeah, okay. Get a hold of this and get prepared. Oh. Okay. Oh. Pendulum, Jacobi, Pendulum trajectory. New chat. Can you plot these functions. I'm going to plot these functions. Okay. I'm pretty sure that GPT would definitely find out that, oh, this guy is trying to plot the pendulum trajectory. Parametric trajectory of pendulum. Here is the plot of the pendulum's trajectory as defined by the parametric equations you provided. The motion traces out a curved arc representing the path of the pendulum bob in two-dimensional space, accounting for the exact solution using elliptic functions rather than the small angle approximation. Exactly. Let me know if you'd like to animate this motion or explore how different values of the initial angle θ0 affect the path. Yes, this is a... Wait a minute. 데이터 분석 한도에 도달했습니다. I'm gonna ignore that. You know, it might be pretty obvious, but I actually have thought that these two equations might not be a new thing in human history, because I'm pretty sure lots and lots of people in the earlier days have already figured out these two equations, like real life pendulum. But you know, I'm kind of glad that I was able to get this out actually using my brain and totally not 100% depending on GPT. If I have to say that the amount of GPT that I was being dependent on GPT, let's say the 0% is like you are a fucking genius, like you are Einstein times 10 million, that level of genius, and you just look at this pendulum. No, you just have to look at the pendulum. The 0% of GPT dependent is just looking at this shit right here, and you go like, holy I get it now. The equations, the mathematics, the whole law of the physics, that is just baffling. It just flows into my brain. My brain is keep handling those such information. Just pure looking at this picture, and just suddenly the stream of the intelligence and information floods into your brain, like the same thing in the last Airbender. You go into avatar state, and you get the informations from the primal ancestors, and you, depending on the information, you will somehow get this thing. That's the 0% of the GPT in dependent, and 100% depending on the GPT. It's just from the start to the end, you write down on the GPT. And that's basically it. Yes, it's 100% dependent, pretty obvious. And if I have to say myself, the amount of me depending on a GPT is that 60%. $57%. Trying to be generous right here. Well, yeah, and I'm not gonna call it a day right here. Well, this is kind of obvious. It's a circle. Who doesn't know that? The trajectory of the pendulum was definitely a circle. But the point is, I want to know the animated, the motion, the animated graphics, depending on the variable t. Okay, so I'm gonna ask the GPT to do it. I wonder if GPT used the same thing as the asymptote does coding. Anyway, can you animate the graphics It's with the variable e. If the result is something like I have reached to my data analysis, I can provide with the Python code to run the pendulum animation on your own system. Would you like that? Okay, here's a complete Python script you can locally to animate the pendulum motion using the parametric equations you provided. Python code for pendulum animation. I like the snake icon on the left. Okay, Python. How to run it? Make sure you have Python installed. Do I have Python installed? Python. I think I do. I think I do. Install the required packages if not already installed. Pip install numpy matplotlib. What does it mean? Python. Is python.exe a thing that... Oh, what the hell did I just do? Okay, GeoGebra, you can go now. I think it's taking time. Yeah. I like, hear me out. I've never... I already have said this, but I have never learned or even had the opportunity to learn about coding. I'm an old-ass boomer. There was no such fucking thing as coding in the school. They didn't even know it existed. There's no coding. But I don't know if there's a thing that I clicked on Python. A window appeared for 1 second. It immediately closed. And I'm currently waiting if something to happen. Now, you know what, this is stupid. I think I did something wrong. Python. Python launcher is sorry to say what? Sorry to say what? It says no pyvnv.cfg file. We can handle that. We can do something about that. This is a screen that popped on right here. Python launcher, of course. Just like Minecraft, everything has a launcher. pyvnv.cfg. pyvnv. Is missing. Oh god. Goodness gracious. It's going to be an epic stream. Look at this right here. This is a very convincing, very trusty. Okay. No pyvnv.cfg file. I made a cfg equals what.cfg. And then made a new file, water.cfg, PyCharm. I have no idea what that is. This automatically made a pyvnv.cfg file. I didn't know what this was, and I was getting errors with my code, and I deleted that file and changed from... I think this is not what I'm looking for right now. Do I really have to Google how to open Python? Jesus, this is very embarrassing. How to open Python. open Python, you will generally use a command line terminal or a Python IDE like IDLE or VS Code or Thonny. On Windows, you can navigate to the Python installation folder and launch Python through the associated files or programs. Command line terminal. Open command prompt or PowerShell. Type Python or py and press enter. Okay, WinR. py. No, I'm actually gonna open the command. Okay. Command prompt. Jesus. Command prompt. Type Python or py and press enter. 씨 뭐야? Okay. I think I have. This will be more efficient way of showing what I'm doing. Hold on, can I show this? Hope I'm not doxing anything. Cannot be careful too much these days, as they say. Yeah. Okay, that's enough. Python 3.13. The Python 3.13 interpreter and runtime. I know I could just wait until like tomorrow midnight and run the script. Let the GPT run the script itself. But something tells me that I cannot totally rely every time on GPT if something does happen, because I want answers now. And if you're watching this right now, and if you're interested in the pendulum trajectory, which has a probability of 0.1%, and well, at least you're here and you want answers, and I cannot discourage your expectations. Okay. 설치됨. Maybe the PYVNG, that shit is the thing, the file that I had with the Python connected to it, and maybe I moved or deleted that file, and Python didn't know what to do. I think that's what it is. Okay. Now I have installed the Python via the Microsoft Store. Now that's definitely going to do something. Okay, Python 3.13.3. I think I did it. I think I did it. Command. Oh, that. Okay. There are some moments that I cannot help myself to jump scare myself. Very weird. Okay. Command prompt. Yeah, I think that. Oh. I'm really afraid if this will dox anything. I mean, seriously though, but I still gotta figure out. Wait. Is there any way to capture the thing, the command prompt, screen capture, window capture, screen capture? What does screen capture do? Oh, okay. This will do. This will do. Yeah, this will do. Okay, you get the fuck out. If I somehow like leak my my address or something, then I don't know. Just try hard not to remember it. Okay. So, what was the thing? The GPT. Make sure to find install required packages not already installed. I think it requires me to copy and paste this one in here. Right. File thing line 1. Pip install numpy my subcp. Syntax error. Invalid syntax. Okay. The Python code. Save the code in a file like pendulum animation.py and run it. Okay. Pendulum. This one. I'm gonna copy it, the whole thing up. I'm gonna copy the whole thing. Okay. Copy the whole thing. Right, yeah, I'm gonna copy the whole thing and put it in the prompt. And 뭐야, 여러 줄인 텍스트를 붙여넣습니다. 이 텍스트를 셀에 붙여넣으면 예기치 않은 명령 실행이 발생할 수 있습니다. 계속 하시겠습니까? Emma, is this going to be the final moments of the Pararang career? I'm actually really being scared right now. There's so many unexpected things happening. Oh shit. Okay. Let me know if you like to add enchantments like the moving pendulum rod or energy blocks. 아이씨. 들어봐. How I have opened up a command, but I don't know here's how to run the pendulum animation on your computer using the code I provided. Okay, step-by-step instructions. Windows. Open a text editor. Use any text editor like Notepad versus Code. Oh, big and powerful. Notepad++. I'm just gonna get the good old Notepad right here. 메모장. Okay. You know what? That kind of reminds me. When I was in the army, paying my service, there was a one dude taught me how to make a homepage, a website, only using Notepad without internet connection. It was basically a demonstration, not an education, but that guy was very interesting guy. He gave me an autograph and told me stay happy. He also wrote that beside the autograph also. Very interesting guy. What was I doing here? Already opened on your computer. Notepad already on your computer. Paste the code. Okay. Is the notepad also a thing that I can capture the window? I'm gonna window cap. Okay, notepad. Okay. If I write down, yeah, you can see it. Good. Paste the code. Copy the full Python code I gave earlier and paste it into your editor. Okay. Save the file. Name the file pendulum animation.py. Pendulum animation.py. Pendulum animation.py. I'm gonna save it. Save it to a folder you can easily find, like your documents folder. Be sure to set save as type. What? To all files, and make sure it ends in .py, not .txt. This sounds very important. Okay, it is in .py. It is on .py. You cannot see it, but it is on .py. Install Python if you haven't already. If you don't already have Python, download from Python. Okay, install it and make sure to check add Python to path when prompted. Add Python to path. You know, something tells me that the Python available in the Microsoft store and here it might be different. Or maybe I don't know, same thing, but add Python to path when prompted. I'm gonna skip this one. I don't think that's important. Open commands prompt. Press Window R. Type CMD and press Enter, and we have the command prompt right here. Okay. Navigate to the folder. Use the cd command. Change directory, for example. My hand is so busy right now. Or if it is in different folder, path to your folder. Example, if you saved it in c.users your name documents, type username. This one I might have to not show it to you guys because I actually have some very personal folder in the directory. I might not just have revealed that. Fuck that. Install required libraries. Type the following in the command prompt only once. Oh, only once. It's scary. What if I type it twice? Initiate system 23 delete. Somebody actually have done that. I'm scared. Okay. CD documents. CD. Well, gotta be kidding me. You guys can't see it, but there's something seems to be wrong with my name of my folders. Of course, there's always some problems involving. I have no idea how many files do I have to close in order to change a single folder's name. It really sucks. And it's actually taking some time longer than I had expected. It's fine, it's okay. What's trying? Jesus. Okay. You know, I think I have to put this into a different directory. Yeah. Come on, what? 뭐 어디다 갖다 놔 이거. 들어봐. I'm gonna name this folder, new folder. I'm gonna name it Goguma. And this file will go into Goguma. Okay. And hopefully this will not return an error. Okay, it didn't return an error. And I'm really eager. Like I'm so desperate. I really have to see the results in my eyes. Okay. For example, the documents in different folder. Yeah, done that. Install required libraries. Type following the command prompt only once. Okay. I'm doing that right now. Default. Whoa. I really want to show this to you guys, but unfortunately I cannot. Hold on. Oh shit. Warning, the script's F2P. Oh. Okay, run the script. Now run the animation by typing Python Pendulum animation.py. You should see a window pop up with the pendulum animation. It is not. Oh, what you? 뭐지 이거? Python 3 figure 1. Okay, Python. This section is longer from the one that I have performed for the entire live stream. It's okay. Well, the Google says that it should be showing, that thing should be showing. I don't think so. You should see a window pop up in there with the pendulum animation. Let me know if you run into any errors or want help customizing it. Wait a minute. Configure subplots. Left, bottom, right, top, double space. Interesting. It opens up a new window, but there's no animation happening. Thanks for trying it out. If a window opens but shows a static image with no animation, it's likely due to one of the following common issues. Let's fix it step by step. Check for missing plt.show or code not running. Sometimes in certain environments, the animation won't display unless plt.show is the very last command in this script. Make sure it looks like this at the end, plt.show. If you have it already, continue to the next step. Do I have that? plt. Do I have to like type it in the command or? Indeed. plt.show. Animation not updating. Try forcing a redraw. Modify the func animation line to force updates by setting delete false and increasing the interval a bit. Then run it again. You know what? What happens if I just like 복사? Okay. plt. Can you show a animation? Yes. Visualize how it looks like. This is your code. This is your fucking code. You provided me this. Why do you mean there's a correction? And you're fighting yourself, literally fighting yourself. Pendulum before. Anyway, if you want to see no matter what, add this to the bottom instead of the PLT show. Okay, might be that. Oh, what? The thing I need. Okay, PLT show. 오케이. 연결 프로그램 메모장에서 편집 plt.show. Okay, this one in the here. FPS 30. I want a 60 FPS. Hopefully this doesn't turn into a problem. You might need to install the video writer backend. Always, please. Pretty sure that it would say it has reached limit. It's okay. Expected this would happen. What was the code of initiating? No, this install. You know what? I think I'm not gonna do this. I'm gonna I'm gonna save it into the file, which is accessible through the membership. Yes, now is a great time to advertise my membership. I think I have a membership, and you'll be able to gain access to the files. And I think I want to bundle this Notepad Python file into the file that I provided you to as members. I think you will have to do this for me. I have no clue. I'm totally lost. Oh, Pendulum. Check for missing PLT that show quarter running. I've done the animation updating for single read while modifying the font animation line for updates by setting complete. Font animation line. Force updates by setting. Run it again. And any font. Okay. And then run it again. I'm gonna run it again. No. Still okay. You cannot see it, but it says X must be a sequence in the command prompt. Runtime error X must be a sequence. Of course, we're running a different environment. Some systems don't play animations well in the default Python window. Try running it in VS Code. Install for Okay, I'm putting an end to here. Yes, that's I had enough. And this makes the Jacobi elliptic functions looks like a toddler's play. This is way more difficult uh, than the mathematical functions that I in my experience. So it's kind of disappointing. Yeah, I was kind of hoping that it will yield the animation. Hmm. Yeah, it says that this limit will refresh after 6:33 a.m. and I am not gonna wait until then. Yeah, but yeah, we finally have this, and like I said, I'll bundle the files, and you'll be able to access that files through the membership. And I think that calls it a day for today's live stream. Hmm. It has been a long journey, but we finally got the equation. Yeah, we got the equations for the trajectory of the pendulum for the x and y. But too bad that the animation sequence was not going well. But we got that, and we learned about Jacobi elliptic functions. And next time I'm gonna bring up a different subject and come back with intriguing and very inspiring mathematical concepts. Okay, that's it for today's live stream.